Yeah, good morning, lady and gentlemen. My name is Eike. I'm the lead of the CDO model repository project at Eclipse. That is a project which has been initiated, I think, approximately 14 years ago. In these 14 years, we have added hundreds of functions over time. Initially, it started with a pure persistence framework, but it includes transactions. Many, we call them cross-cutting or orthogonal functions. Orthogonal because you typically use eCore to model your business domain. Maybe you use UML, but that is based on eCore. So in that phase, you can focus on your business concerns, and at some point, you typically want to deploy it to some networking infrastructure, distributed applications that use these models. And CDO tries to help you in many ways to address these orthogonal concerns. And most of them you see here. For all of them, CDO provides nice APIs that you can use in your applications. Many of them, not all of them, but many of them are covered with user interface components that we provide, that you can also use in your applications, or that we use to provide an exemplary user interface to work with the model repository. I'll show a few slides that show the basic functionality of CDO. Then I'd like to give a longer demo. And if we have time left, I could try to explain how CDO achieves all the things that I showed to you. So you have an EMF application and deploy that application to multiple network nodes. When they start up, they typically connect to the central CDO repository and communicate with it. And typically, the user of an application or a background job modifies an object or multiple objects in a CDO transaction, commits this transaction to the central server, and the server sends notifications to the other clients to inform them that parts of the model have changed. When the other applications access these objects again, they are transparently reloaded from the server. All of that is very configurable. You can, for example, configure a CDO to immediately send the change deltas from the server to all the other clients, or to preload them. So there are plenty of policies that you can hook into CDO to configure these aspects. Some of them will be covered in my talk on Thursday, 7 recipes for CDO. I'll give another hint at the end of this demo. So how does that look like in the central model repository? You see, in the application, you deal with EMF objects, E-objects. The server doesn't know about E-objects. We call them CDO revisions. So when an application commits a transaction, the first version of these objects is created in the server. And the single bullets there we call 3 revisions. That's a little bit different from other version control systems where they say the baseline, so all the changes is a revision, but that's just naming. So in the normal mode of a repository, the next transaction changes the revisions in the server. So you always see the latest state of the model in the database, in the underlying database. There's a second mode of the server, which we call auditing mode. And in this auditing mode, the same sequence of modifications looks like this. So the old revisions, the old versions are not thrown away, they are kept, and you can, I will demo that later, you can rewind your model into the past, so you can time travel through your model. And the third mode that the server offers is called branching. And you see the auditing mode added another dimension in the revision space in the server. And the branching mode adds a third dimension. So in each branch you keep the history and you can go back and forth in time. Okay, I like to show you a demo of this. And since a few years we have a nice exemplary user interface. Actually, it's a little bit more than exemplary. It has been developed for the CEA in France, and they use it in Papyrus as a real user interface. But it is reusable, so you can decide what parts of this user interface you want to use in your application. So the main view of this user interface is the repositories view, and you have basically two choices. Either you already have an existing CDO server running somewhere in your company, then you can connect to it, but for test purposes it's very easy to create a new local repository here. You can pick one of these three modes that we just saw. And in this case, I say, I want to make this repository available in the network under this port. So there we go. Now you can check out the entire repository from here. And you get a project, something like a project in the Project Explorer of Eclipse. But there are no files associated with it. It's really more like a database connection to this repository there. So from here we can create a folder structure within the repository, or create model resources, binary files and text files. It will all be stored in the database of the repository. So let's work with a model resource. You can either add components or elements to this resource through the Project Explorer directly. For example, our shipped example model, which is the company model, this one here. So you can add a company directly from here. So before we add more elements to the model, I'd like to use this second Eclipse client. It's really a second process. It's not just another window. It could be on a different computer. So here we connect to an existing repository, the one that we see here in this process. So it has found it already. It recognized that it is a replicable branching repository. One word regarding replicable. A few years ago we added the capability to create clone repositories in the network or even locally. The local clones I will show later. So now we are connected here. We create a checkout from this repository. By the way, you can create any number of checkouts. That is just a matter of microseconds. I delete the second checkout and open an editor on the model resources here. So now you see what a CDO transaction is. When I change the name of the company to, let's say, Eclipse, you see that the element is dirty, but it is not yet committed to the repository. Only when I save the entire resource, all the changes in the repository in all resources are committed atomically. And you see the other client immediately updates. And this updating of the UI, you don't have to program anything. the user interface has normal EMF adapters, they are notified. So the model behaves on both sides as if it was modified by the local side. This is why we used to call CDO a distributed shared model. So let me add a number of elements to this model. Let's say I'm a supplier of Eclipse. And I save it. And immediately you see it here. Add is another, or let me use Cedric. Cedric is a supplier. And of course you can do that on both sides. So we have a category software, save it, and add EMF and CDO. Oops. CDO as products. And now you notice that both of these transactions are not committed yet. So let me commit CDO, EMF first. That existed before. So now you see that the category software is dirty here, and actually that was a bad example. The EMF was already merged into the dirty software category on the right side. So this was an example of non-interactive automated merge in CDO. So I can just save it on the right side, and you see both are in sync already. Because this was a trivial conflict, this was solved automatically. It is of course different if I change the category name to modeling here and to foo on the left side. So now if I save the right editor, you immediately see this here red. That means it's not just dirty, it's a dirty conflict now, and CDO can't solve it. So if I try to commit it, I have two choices. Either I can roll back this transaction, and that means it gets to the latest state, so it will look like this one here, and I could apply my changes again. Or I merge it manually with EMF compare, and now I can say accept my changes, I hope. Oh Jesus. That hasn't happened in a while. I think it's just the left client which hung up. It's probably a bug in EMF compare. Okay, let me kill that one. That's client one. Okay. Okay, I think I have to look at merging. So what else did I want to show? So now you saw how conflicts can come up in distributed model editing. In principle, you can merge them, but in many cases you just don't want that. You want to prevent the conflicts, and what you need is explicit locking. And CDO supports that with many interesting functions. In the user interface, it's very easy. You can, for example, lock the entire modeling category. Then you say lock this tree, and this entire tree is locked atomically in the server. And now if you try to change it, interesting, the UI didn't react to this locked object. That's not a good thing. But I can just roll it back. So at least the left side can now change it back to software. And when you commit the transaction, all the locks are released. A new feature is that if you lock a tree, you can tell, okay, this object, I don't want to release the lock automatically when I commit the next time. So if I change it and commit it, you will see that this object stays locked. So you have very fine granular control over what objects will be locked and will stay locked. So I'll unlock this object manually. So what else could I show? You could ask, why do I have to check out from this repository? This concept of a checkout is really just a UI directive. It doesn't exist on the CDO core layer. We introduced it because there are different types of checkouts, and you can see that here. By default, you create an online checkout, so that's really like a remote connection to a database, and it is transactional. That means you can change the model that you checked out. You can also create, if you want to, in parallel, a historical checkout. So you say, check out the entire repository, and you see it looks the same, right? So I open another editor. But on this checkout, you can show our time machine. And that is just a simple slider. And here you can rewind all the changes until before the model existed. And this is really just 3 lines of code. You can do that in your application as well. So then we have another kind of checkout, are offline checkouts. And let me do that in this instance here. So I check out from the repository. Again, it looks the same, a little bit different. You see there are local object states annotated to the model elements. So why is this different? I can show that. What would happen if I disconnect this repository? This was the local repository. If I disconnect it, that means this here will disconnect, it loses the connection as well, and all the checkouts from these two will be closed as well, except the offline one that can continue to be used. So you can change the name of an element, CDO2. Now you see it's locally dirty. If I connect this local repository, then connect this remote one, open this checkout here, and of course here it is still not renamed, but now I can check in from this offline checkout, and you see immediately that the other checkouts display this change that has been merged into the repository. What else could I show? An interesting thing is maybe to show how you use CDO APIs in your applications. I prepared a nice example. So we only need, well, we can show 2 checkouts here. And I'll place them here in the upper part of the screen. And in a third Eclipse instance, I prepared a small program Can you read that? Yeah. Great. This is a standalone Java program. So you can use CDO. It comes as Eclipse plugins, but you can also use them in standalone programs, in web containers or whatever. The bootstrapping or the configuration of the application is a little bit easier in Eclipse. If you run a program standalone, you have to initialize a number of things, not many, but so in Eclipse this block would typically not appear. The main code of this program does the following. It opens a TCP connection to the local host on this port, and you remember that was the port where this repository listened. And this connection here is a Net4j connection. Net4j has been developed especially for CDO, but later decoupled from it, so you could even use that alone. This is a small example. This is all you need to do to open a connection. And then you want to open a CDO session through this TCP connection. This is done in 1, 2, 3, 4 lines here. So we use this connector, we say what repository on that server, and then we open a CDO session. With this session you can already do many things, like creating branches or deleting them, renaming them, accessing all the eCore packages in the server, adding new ones, and a bunch of other things, but you cannot modify models. You need a transaction for that. But you see, opening a transaction is as easy as this. Actually, this is the simplest form of opening a transaction. Then you can access the Model 1 resource, that is this one here. From here on, this CDO resource is actually an EMF resource. So from this point on, you can use normal EMF APIs to navigate through your model, modify instances, and when you want to save them, you commit the transaction. So what are we doing here? We get the company out of this resource and append an X to the name of the company. And we do that in a loop until I hit a key. So if I run this program, you see that the X's appear in all the clients in the network. So what would happen if I try to change it back to Eclipse here? That's not easily possible because it's 1000 milliseconds, 1 second delay in this loop, and I'm just not fast enough. So what could I do to change this object here? Does someone know? Question? Nobody? You would put a lock on it. Then our standalone client cannot commit its transaction successfully. So we say lock this object, and I think in the console here you would, after there's a configurable locking timeout, I think it's 10 seconds, so after 10 seconds you would see the message, couldn't lock the object after 10,000 milliseconds. So now I can change it back to Eclipse. And when I save it, you know the lock is released automatically. so the access come again and again. Yeah, I think you got an impression that with CDO you can easily build cool model applications. You can distribute them in networks. Your applications can collaborate with each other. There are many, many more things you can do with CDO. Of course, there's history support. So here you would see all the changes. All of this here is accessible through APIs. And you see it's all very, very reactive. So even the history automatically responds to remote changes, stuff like that. If I create a branch in this repository, let's say team A branch, you would also immediately see that in the entire network. That's a basic principle of CDO, that what you do on one computer, by default you see it on all the others, unless you do something to delay it or whatever. Okay, how much time is left? 10 minutes. Okay, so I would say either you have questions. If not, I could show a number of some more technical slides in case you're interested how we do this, because EMF by itself is not immediately able to do all these things. But maybe first opportunity for questions. Yes, please.
On the server side, can you have redundant servers or failover or something like that?
Yes. So I repeat the question. The question was, can we have redundant servers, failover support? And yes, it requires that you use branching, but we have failover monitors, and you can have any number of servers put into a failover cluster. And at the same time, you can have cloned servers that have a constant connection to the master server. Well, actually not constant, but if it loses connection, it continues to operate. For example, you can serve a site facility of your company while you have an online connection to the master. Everything goes immediately into the master, and if you're disconnected, this site branch can still continue to work and have clients connected. And you can combine that with failover servers as well. Other questions? Okay, then I think I use the remaining minutes to show you how this works. You remember, this is a revision in CDO. A revision, I'll hurry through it a little bit, has a number of EMF modeled attributes. They are all in this generic array, and we store additional EMF specific or CDO specific information in them. And these revisions, they are really self-contained. They have no pointers to other model elements. They are like data transfer objects. You can serialize them, put them in a database, send them over a network wire, and that makes it easy to work with them. This CDO session that we saw is based on this Net4j protocol, which you see here. It has, among other things, a lazy package registry where you can access all the packages in the server. And one of the most important facilities is the revision manager. And you see here, a logical object has a technical ID here, 1, 2, 3, and so on. And the revision manager caches the loaded revisions of these objects, and it also loads them from the server if they are not in the cache already. So an example with just one object. These circles are always objects, so this object number 1 and a view is basically like a read-only transaction. And I mentioned you need a transaction or a view to access the objects. It is wired with this revision, because the revision carries the model state of the object. The E-object itself in CDO has no model state associated. By the way, why is that? And I think I forgot to mention that. With CDO, you can have arbitrarily large models. They don't depend on your, they are not limited by the size of your local memory. You will see that in a minute, I think. So we have three types of these views. The normal ones, you can just read a model. They always show you the latest state of an object. An audit view can show you a former state of the entire model, and it picks the right revision from the time that you configure into the audit. And the third type is a transaction. It also shows you the latest state of a model, because you can only change the latest state. So if you change the object through the transaction, the revision is copied into the transaction, changed there. When you commit the transaction, it's sent over the wire to the server, it's persisted, sent to other clients, comes back to this client. And you saw that all the views that show the latest state of the model changed the pointer to this other revision and notify the application on top of them. And that is how all this distribution and collaboration works. How can an EMF object do something like this? So if we look at an example, the book impl of EMF, there is actually one pointer. I think this is an enum, that's irrelevant, but this is a pointer to another class or object. And in normal EMF, this would be a strong Java pointer, and that ties together all the elements in your model, and they cannot be garbage collected anymore. So with normal EMF, you're limited by your local memory size. We didn't want that in CDO, so we cut out all the generated fields from your classes. And we do that with a simple switch in the gen model. It's called reflective delegation. And of course, this information must go somewhere, so we inject another base class, and we do that with this second generator switch, which is called root extends class. And so a normal EMF object extends E-object impl, more or less. And our CDO object impl is in the middle of the two, so it just adds functionality. And what does it add? It remembers the technical ID of an object, a pointer to the revision. That's the one you saw in the previous slide, which can swap back and forth. It knows the local state of the object, new, dirty, clean, conflict, and so on. And it knows to what CDO view or transaction it belongs. So I think time's running now, so I quickly show you the internal state machine of CDO. It's a little bit similar to Hibernate, I think, except that in CDO we have these remote invalidate events. They are created when the server sends notifications to the other clients. And you saw this transition here in my demo. There I had a conflict, but there was a conflict resolver configured, and that resolved the conflict automatically. So CDO can work with two kinds of models. We call them native and legacy models. Normal EMF models are, from a CDO perspective, legacy models, and CDO can work with them through our legacy adapter layer. But when you really have large models and you want these scalability benefits, then you need to regenerate your model for CDO, and then we call it a CDO native model. You can also work with dynamic objects, so you can you don't have to use generated models at all. You can just import an eCore file into the repository and create instances. And this is an example, a built-in example of a CDO native model that is the internal file system structure in a CDO repository. It's just modeled with eCore, generated for CDO, slightly modified, and then used as the internal file system, which you have seen in the demo. Okay, I'd like to thank you for listening and remind you again, I was too quick, remind you again to my talk on Thursday, where we dive deeper into some technical details. 7 of them. The talk is called 7 Recipes for CDO, and it's on Thursday morning. If you're interested, it would be great to see you there. Thank you.